Okay, so in the previous tutorial, I think we have done this wall detection heuristic. Yeah, so the character, when he's hitting the wall, we are not playing any sort of a cycle animation or movement related animation, right? So that's the wall detection. And now we can move to the inverse kinematic based logics. For example, let's say uh, if our character is step into a sloped floor, then the character's foot placement should be automatically resolved, right? So I will show you what this inverse kinematic thing means. And actually currently we haven't implemented it yet. So you will see what's the issue. So let's say this is a floor which has angular damping like this. Maybe I'll have this one. Right. So now if our character step into this flow, maybe I'll show you in the full screen mode. Right. So if our character step into this flow, you see the foot placement is wrong. See, the left foot is inside the platform and the right foot is just floating away from the platform, because actually the skeleton is currently not supported any sort of inverse kinematic related features. And let's say if I step out of this platform severely, something like this, you can see his left foot is completely floating at the air, right? So this is not quite accurate and we have to fix it, right? So the fix is quite easy actually. In Unreal Engine by default, the mannequin is well rigged, right? So if you go into the characters, mannequin and mesh, and inside the SK mannequin, you can see by default they have been added all the necessary inverse kinematic related pivots for us, right? So for example, this IK foot L is there, and that bone can be used to manipulate, or that inverse kinematic socket can be used to manipulate this specific bone, right? So I will undo any sort of translations here. So based on these sort of IK pivot points, we can apply the inverse kinematics, right? So I'll rotate the flow again. Yeah. So actually the solution is quite simple. All we have to do is go to the ABP locomotion anim instance, and inside the anim graph, once this locomotion cast post has been applied, we have to apply the inverse kinematics, right? So maybe I can use this turn in place cache post, because here we capture the locomotion, right? So maybe I'll comment this thing as locomotion, and here we cache the turn in place related root bone transformations. So maybe I'll comment this as turn in place, right? And now we can apply the inverse kinematics based on the control rig, right? So let's drag this pin and search for control rig. So under the miscellaneous, we have this node, control rig, right? So we can use this pin to apply the kinematics of IK for our character. Mm, so the currently the alpha is 1, which means uh, the IK will be applied entirely. Mm, and yeah, first let's compile and save, and here it gives some error. It says linked graph node controlling has no valid instance class to spawn. Mm, why is that? Yeah, so I found the issue. Basically, yeah, this is control rig pin should point or should reference for a specific control rig class, right? Otherwise, it doesn't know about what sort of bone manipulations it has to be done dynamically, right? Uh, so here, if you select this control rig pin and go down, here we have this control rig class variable. So if you look at the drop down, actually by default Unreal Engine provide these uh, 3 control rigs for us. So you can see it comes from the TPS game essential characters mannequins rigs folder. So if I go there, characters mannequins rigs folder, here we have like set of predefined control rigs that we can use, right? And I think this for these sort of body foot placements, we can use this basic foot IK, right? So you can go inside that IK definition, a control rig, and here you can see set of predefined configurations are there for us, right? So you don't need to actually do all those bone manipulations by yourself. But if you are going for a custom character or with a custom mannequin, then you may have to design your own control rig class for that specific character. But if you are using the default Unreal Engine character based or Unreal Engine characters mannequin skeleton based characters, then you don't need to predefine or redefine the control rig. Instead, you can simply reuse this existing one, right? So let's go to the control rig and let's assign this CR mannequin basic foot IK and compile and save it again, right? Um, Now it actually exposes this pin as well, right? Uh, should do IK trace pin. Actually, even if this is looks like a pin at the control rig level, it's just a variable, right? It's just a publicly exposed variable. Uh, so in this control rig node, it will show you like a pin, right? And let's use this pin as well. So later on, we can actually toggle the IK trace at runtime, right? But for now, I will simply make it true. So the control rig based IK will be applied. Right? Now let's play. Okay, now you can see the foot placement is correct, right? The character's foot is now not floating or intersecting with the floor anymore, right? And what if I go outside of the floor? Yeah, now you can see character's left foot is inside the platform and the right foot is outside the platform and in the ground, right? And if I rotate, it dynamically resolves those IKs for us, right? Awesome. Okay. Now, if I disable this should do IK trace, compile and play it again, now you can see IK is not applied, right? Okay. So maybe we can use this pin later on when we are looking at the jump related features, because when the character is jumping we don't need to consider this control rig dynamics, right? In such cases actually we can dynamically disable this IK trace by toggling this variable, right? But for now let's keep it as true. Okay, the other thing is this alpha. So this alpha should be resolved dynamically as well, right? For example, if it is 0, you can see the IK rig will not be applied. See, it has not been applied. But let's say if you make it 0.5 and play it again, it is applied but partially, right? You can see the foot placements. It is being applied but not entirely, right? So at the runtime, actually, we can change this alpha dynamically as well, such a way that it will not apply this control rig based bond manipulations at every time for each frame rendering, right? Because this is an expensive task, right? So if you look at the control rig, you can see there are multiple different bond manipulations rules that has been applied, right? So if you are doing all of these manipulations at runtime for each frame, it's a performance hit, right? Because this is just a one character, but let's say there are hundreds of npc characters moving in your level, and you are doing all of these board manipulations at runtime for each character, then it's a huge performance bottleneck. So in order to have an optimized workflow, I think we have to resolve this alpha dynamically as well, which means like whenever we require the control rig board manipulations, then we make the alpha 1, or whenever we doesn't require it like entirely, we can reduce this alpha in such a way that that bond manipulations will be reduced, right? And if we need to disable it entirely, then we simply toggle this should do IK trace. Okay, right. So in order to do that, let's first create a variable for this IK alpha. I'll name it as IK alpha and assign it to a category called skeletal control data. Okay. Now at the blueprint thread safe update animation function, I have all of these logics that has been applied, and after this is first update node, let's get the IK alpha and let's f interp to for a specific target value, right? And for the delta time, I can get the existing delta time, which is returned from this node, right? And the interim speed, maybe 10 would be fine. And the target value should be 0 or 1. Yeah, it should be 1 because it will f interp from 0 to 1 dynamically, right? And let's set the alpha, right? Compile and save it again. Okay, and let's play test it again. Yeah, now you can see actually the IK is being applied, but it's happening at dynamically, right? You see the IK placement is now a bit smooth, right? It doesn't quickly jump to the ground, right? It's not quickly snapped out of the platform and directly go to the ground. Instead of that, it smoothly go to the ground, you see, because the IK alpha is increasing dynamically, right? So it's a bit more realistic than what we had before. Okay, and the next thing is, as I mentioned before, we can dynamically resolve this target alpha, right? Which means like it's not necessary to necessarily go to 1, and sometimes let's say for some movements we may need to disable this alpha, right? So I think some of the animations have a curve called disable leg IK. So if I go to the, I don't know exactly which sort of animations has that curve name. But maybe let's look at left start. Yeah, we have these curves actually. Distance curve is there. And this doesn't have any curves. And how about crouch? Yeah, crouch also doesn't have anything. I'm not quite sure, but some of the animations may have curve called disable leg IK, which means like whenever that specific curve has been applied, we can disable the IK alpha, right? For example, let's say if I look at this jog left, maybe jog left start, it has a distance curve, right? And the distance curve value is increasing over the time, something like that. We can add a new curve called disable leg IK, and we can have sort of a curve variation there, and based on the valuation we can dynamically apply those changes at our animation blueprint level, right? Because this is rendering for each frame, right? Okay, so to do that, let's get a value function, and here I'll assign the curve name called disable leg IK, and I think we have a dedicated group for curves, right? Yeah, so here we have the dedicated variables for curves. So let's promote this to a variable called curve disable leg IK. Assign it to this category and compile. So now we have this default value here. Right, so if I'll simply check if the curve value is greater than 0, which indicate we have to apply that IK disable feature for our IK. So maybe I'll promote this to a variable called disable control, and maybe we can move it to frame checks, and add it to here, add it to here. Right, so this is the one logic. And then maybe we can directly disable our control rig as well. So I'll have a new variable called disable leg IK. So we don't need to manually toggle that should do IK trace pin again and again. Instead of that, we can simply toggle this disable leg IK. So I will move it to the settings category, right? And by default, I'll make it as false, which means like by default, the leg IK has been enabled, right? So let's have O boolean node here, right? And then yeah, let's first test these two together. So disable leg IK, and here now let's have a select plot based on the disable control rig, right? And if the control rig is disabled, then pick A should be 0, and if not, which means it will pick B, which means 1. Okay, compile, save, and let's play. You can see these animations actually have the IK, and it doesn't involve any sort of disable leg IK curve. Therefore, actually, it applies the IK, right? And let's say if I disable control rig from this variable and play it again, you can see the IK is not applied now. Oh, it has been applied. How is that? Disable control rig. Oh, sorry. Not this one. It should be under settings. Disable leg IK. Okay. Now let's play. Yeah, now you can see the IK is not being applied. Okay. So I'll make it false again. Compile and save. And then one other thing is like when the character is moving, we don't need to necessarily apply leg IK alpha, right? Because it is not significant to apply any sort of IK alpha because the player will not notice those sort of inverse kinematics at the playtime, right? Only at these sort of idle states we have to properly resolve the IK in order to minimize any sort of issues, right? Which means like when we are accelerating, right, when the character is moving, we are not applying the IK bone manipulations. Okay. Right. Since those are sort of optimized features, maybe we can add these to the anim set config levels, right? Because let's say if some person need to have much more realistic animation and even applying inverse kinematics at the runtime while the character is moving, then he may apply those IKs by configuring those specific variables, right? Plus, I think this disable leg IK is a configurable variable, and I think it should be goes under the config, right? Then the developers don't need to actually manually manipulate these sort of variables at the ABP locomotion level, right? Okay, so I'll go to the at our data table, and inside the config now we have these sort of configurations. So let's add few more to it, right? So let's go to the data structure, it's an im set, right? And it is pointing to the movement anim config, right? So let's add a variable for disable leg IK and another one for disable leg IK while moving. Okay, so by default I'll keep this as false. Save it, and let's go to the SNE movement. Save it as well, so we are good to go. Then let's go to the SNE movement group. Save it, good to go. And finally, not finally actually, we have to go to the general SNE sprint. Save it, SNE general, save it, and finally SNE set, save it. Okay, all of those are now good to go. And let's go to the data table level, save it back, nothing crashes. And let's go to the blueprint component level, compile and save. Okay, so make sure to follow this exact same saving procedure. Otherwise, if you simply click save all, what will happen is like some of the references at these data structures will be at some inconsistent level, inconsistent state, right? So the compilations may fail and even sometimes the engine may crash, right? Okay, now we have those configurable variables at our data table level. You can see for walk and for jog and for crouch, now we have those configurable variables. Okay, so let's quickly jump back to the ABP locomotion and let's take those variables inside the ABP locomotion graph. So I think we have a not thread safe function called set animation data, and inside of it we have this configs collapsed graph, right? And let's take this disable leg ik and let's apply it to this disable leg ik variable, right? So we don't need to manually manipulate it from the ABP instance level. And let's promote this to a variable as well, disable leg ik while moving, right? And assign it to category call maybe settings and plug it here. Right, now let's go back to the blueprint thread safe update function, and there we can add a new rule called if disable leg L moving is true and if we have an acceleration, then we can disable the ik, right? But again, this is a configurable value, so if a person doesn't need to have extremely realistic ik placements, then he can disable this leg ik movement. So ultimately, when the character is moving, this output pin will return true value, which means it will make this disable control rig is true, which means its target float will be 0, right? So at the runtime, when the ik alpha is 0, yeah, I think we have to make the ik alpha is 0 by default, otherwise it may not work properly, right? Compile and save. And by default ik alpha is 0 and it is pointing to the target value for 0. So at the delta time, it will be interpolated to 0, which means like there is no interpolation, right? Which means the ik alpha is 0. Then it will go to the anim graph and it will apply to the alpha as 0, which means the control rig won't be applied, right? So that's the entire flow of that control rig activation, right? If I play it now, you can see now everything's applied properly. And if I try to move, you can see currently we haven't disabled any ik. So when I'm moving, even at the platform, the foot placement is applied properly. But let's say at the data table and set level, maybe when I'm jogging, let's say if I disable leg ik while moving as true and save it again and play, now you can see whenever I'm moving, that leg ik is not being applied, okay? So it's a performance enabled feature, but it's may not be quite realistic, right? But if I enable, which means we haven't disabled the leg movement, leg ik while moving, if I play it again, you will see ik has been applied, okay? So it's pretty much realistic, but it will have sort of a performance overhead, right? So it's all up to the player, right? And maybe one more future improvements that we can do is we can toggle these leg IK based on the LOD, right? Which means level of detail. For example, let's say if we have NPC characters that are in very far distance, then we don't need to apply the IK, right? Because their foot placement or their movements are not quite visible enough, right? So we can disable the IK based on the LOD levels as well. But those are future improvements that we can follow up, and let's consider those stuff in future. But for now, I think we have a very nice setup for handling the control rig at runtime. Okay, so that's the control rig manipulations, and I'll see you in the next one. Thank you.